Hey everyone, how are we doing? Got Tiffany here and Mohammed here. How is everyone doing? Mohammed, dope. Hey everyone, how are we doing? Got Tiffany here and Mohammed here. There we go. Sorry, I had myself playing in the background. Get the stream loaded up, get everything going. Good to go. Do you have FPP3 loaded up? That is the name of the package, Mohammed. Tell me if you don't have it loaded up after this. If it's not working, we'll take a look. Tiffany's got the first question here. We getting rocking and rolling, ready to go. Chapter 6, particularly powerful hurricane. Doing well. Thank you, Tiffany. I appreciate that. Let's throw out some points. Particularly powerful hurricane force winds extend 120 miles from its center. The hurricane was a big storm. Cool. Let's check it out. And I think Snea had number 5 from 474. We'll check that out. Access denied. My Pearson's not letting me do work anymore. Access denied to my Pearson. Nope. Well, no more my Pearson today. It says access denied. Had some waffles from HEB. Really great grocery store we have around here. HEB. Getting chapter 6 loaded up. Is this the quiz or is this the homework? Hey, Rachel, good to see you here. Is this the quiz or is it the homework? I think it's on the quiz also. Let's go check out the... I think it's on the quiz. I know it's on the quiz. I don't know if it's on the homework. Okay. Finding the particularly powerful hurricane. A particularly powerful hurricane. Here we go. We found it. Let's go check this out. Chapter 5 homework. You bet. We'll do it here next. You got it. Can we check? Yeah, let's do it. We got a bunch of great questions. Hannah, great to see you. John, good to see you. I love your icon, John. Is it Kermit? Cracks me up every time I see that in the chat. Let's go check this out. Here we go. First question on the docket today is a particularly powerful hurricane has winds that extend 120 miles from its center. The hurricane was a big storm, and this affects how we think about prediction errors. Suppose we add 120 miles to get an idea of how far from the predicted track we might find damaging winds. Explain what would happen to the correlation between prediction error and year. So, I want you to think about this. Would you say your grade on the test, yes or no, is correlated to how much you study? Yes or no? Would you say your grade on the test is correlated to how much you study? Correlated means that there's either like some positive, negative relationship. Do we still have that open? We were talking about this a few days ago. Correlation is going to be in the terms of like positive or negative. And so do you think there's a correlation? We might not have any of those graphics open from when we talked about correlation. Do you think, I would say it's correlated too. So correlation in this sense, we're talking about a positive because it goes up. Here's your hours studied. And great job, everybody. 20 points. Is Mewbot here giving out points? I don't think Mewbot's awake. Mewbot, wake up. Wake up, Mewbot. He's going to crash the world behind me. World-destroying Mewbot. I was a little afraid the world wasn't going to come back. So this is your study right here. And this is your grade. Beautiful handwriting. Amazing. And we would see a positive linear correlation of sorts, it looks like, at least with that graphic. Now, if I go here and I add, this is where our question comes into play. If I add in 10 points to everyone's grade, so I go to everyone's grade and add in 10 points like this question's saying we're doing, what's going to happen to the correlation between how long you studied and your grade? Just take a moment to think. If everyone gets 10 points, would it change the correlation of how long people studied in their grade? We're just going to add 10 points to everyone's grades. Everyone gets 10 points. So boom, all grades go higher. What would happen to the correlation of how long you studied? You bet, Roger. Yep. Would it go up, though? Everyone gets 10 points. So everyone gets 10 points. So the people who studied the most, and we would hope, people who studied the most, we would hope what? Would get the highest grades. People who studied the least might get the lowest grades. But we're just adding a flat 10 points to everyone's grades. So watch this. This is why I love R. Let's go here, and let's make some grades. You ready? Watch this. Grades. Here's the grades in the class. Amazing grades. Just a quick vector of grades. And here's the hours studied. Does this... Who can understand? I know you don't code in R, but does everyone understand? We need a little bit of variation right here. Does everyone understand what you're seeing right here? Like how many hours people study for the test and their grades. Does that make sense? We have how long people studied and their grade. So we can say, let's plot this. And what are we going to see? If we plot this, We plot people's grades as the Y. Actually, that's going to do the X. And then we plot hours studied. So let's see what this looks like if we take a look at the plot. And what do we see? There's a somewhat positive linear relationship for those who studied more, make higher grades. But let's look at the correlation, which is the chapter we're going to get to right here. We're going to look at the correlation of X and Y. And so the correlation, I don't usually do correlation this way, but it's this. What about if we were to go to grades and we were to add to people's grades 10 points? So let's call this grades plus 10. Does that make sense? I have now put in people's grades plus 10 and watch this graphic. I want you to look at this graphic very closely and see what happens. Did you see it? How does it look when I add 10 to it? You're seeing it. This is grades plus 10 now. And the correlation, which was 0.98, when we add 10 points to everyone's grades, is 0.98. Because what it's doing is it's just raising everyone's grades up. The relationship between X and Y has not changed. So changing the Y by a constant unit change would still have the Y values spread out the same way. So the relationship between X and Y remains constant. So adding a constant to the values doesn't do anything to because we're not changing how X and Y are connected. We're looking at the connection between how long people study and their grades. Like in this problem, we're looking at the connection between the year and the prediction error. So the sign of the correlation would not change. And the magnitude of the correlation, like how strong it is, would not change. Because the z-scores, and that's the standardized metrics, upon the correlation is based, would not change. And that last part's a little bit confusing. When you do correlation, you're actually just getting z-score, which is a scaling of the vector. So if you look at the z-score of these, here's the z-score of these, and here's the z-score of the other ones. So we can get z-scores very quickly with code, and you'll notice the z-scores are identical. And since z-scores are standardized, adding a constant would not change the z-scores, because if you scored the mean, like if the test average was an 80 and I gave everyone 10 points, where would you be at if you have an 80? Last question here on this one. If you got an 80 on the test, and so you're the mean, and then I give everyone 10 points, where would you still be at? If the test average was an 80 and I give everyone 10 points, where would you still be at? You'd be at a 90, and 90 would be the... Boom, Tiffany, right there. That's exactly what I want to hear. 90 would be the new mean. So it's standardized. You'd be at a 90, and 90 is the new mean, so your z-score would not change. So you'd go from being an 80, like pretending that person has the 80 right there, and now you're a 90 because I gave everyone 10 points, but you're still the mean. It's just it's been shifted over a little bit. You will use software chapter 6 a little bit. I can show some of that. We'll probably do one of those problems here coming up soon. Thank you so much, Tiffany. Great question, Tiffany. Let's do another one. We're going to keep just going question by question by question. Mohammed, if you didn't hear what I said earlier, let me know. I'm gonna do your second question a little bit here. We're gonna do a chapter 5 from John right here. Find the percent area to the right of 0.95. This one, let's go check it out. So we're gonna get this set up right here. Little music. We're gonna need some David M. Lane for this one. Let's go check this out. We're gonna knock out as many questions as we can today. So check this out. Go to the David M. Lane and let's check out the area to left, right, or below the curve. And 1 second as I get this all pulled up. I'm gonna get the screen looking nice and pretty. Okay. Oh, do I not have a David M. Lane up? Okay. Here's the David M. Lane. Okay, we'll be ready here in just a second. Okay, I think we are good to go. Wait, where'd my thing go? There we go, and here we go. Let's go do the percent of areas on chapter 5. Yeah, perfect, Kayla. Great timing. Let's go do some chapter 5 percent of areas to the left, right, between, or above on the normal curve. Let's go check it out. So the goal with this problem right here is to have the David M. Lane open. I just dropped it in the chat right there. On the test, you will not use the applet. Awesome, Rachel. I'll see you here in just a moment, and I'll do your question. We'll be doing them all, so if you dropped a question, we'll make sure to get it done. So the goal is to make your applet look like the picture, and then on the test, you may have to look at pictures of the applet. We have a lot of Canvas content questions that show how the test could look. Oh, there was our correlation. We were looking for that a second ago. So you can see example questions from your Canvas content that gives you information that then you might have to solve using the picture below. So you could get a picture of the applet that could explain to you what it's showing, and then you'll have to use that information to figure out the question. In this instance, though, we're going to make the applet look like this. So we want the area greater than 1.2. First step to do is find the picture that looks like that. 1.2 is on the right side of the curve. Notice where it's over here. So we're going to find greater than 1.2 and go to this first button right here. And we're going to put in 1.2. Got a little bigger. Perfect. And there we go. Excellent. I'm going to disappear for now. So we're going to make our picture up here look like this over here, and we know we have the right answer when that happens. So now looking at this, we see the answer right here is going to be the following. Hey, Frankie, good to see you here. Let's throw some points for everybody in the chat. Awesome work. So we got the right answer there, and we're just going to make sure to move our decimals. Be very careful moving the decimals. Mistakes can happen. So now we're going to go right here to the next one, and we want the area less than 1.5. So we want to go less than, but be careful. 1.5 is on the right side of the curve, so we want over here. Make your picture look like it to confirm, and then double check by reading the area less than 1.5. I've definitely made a mistake or two choosing the wrong direction to shade. The answer is once again going to be this, but make sure to put it in as a percent and use the 2 decimals right here to not make an error. Now, the interesting thing about this problem is it actually goes in order. The next one is a between. We're going between these two values, and this is almost 50%. It's going to be very close to 50 from the numbers I know on the curve. You're not meant to know the numbers this exactly, but you should probably know it's less than 68 because it's within the 1 and -1. Like I said, it'd be very close to 50. But does that make sense? Who's with me on this? I'm going to slow it down just here a little bit. Would you be able to tell me that the area I've shaded is less than 68%? And why does Brian know that this area here has to be less than 68? Take a moment and pause. The answer is on the screen for how to get this one. We go to the between on the David M. Lane. And why does this have to be less than 68? This area right here. I'm kind of pointing to why it has to be. Using empirical rule numbers. So if you had a test question that asked this, we might give you like multiple choice to be like, what's the answer? And if we put 70%, you'd be like, nope, can't be 70%. Why would you know that this area I've shaded right here has to be less than 68? Take a moment to think it through and be like, why would I know just looking at this that this has to be less than 68? And remember how our normal curve works. On our normal curve, the middle, exactly, Kayla, great job, 50 points right there, because 68 is between 1 and -1, so it has to be less than 68. So that's how we can kind of ask test questions. Great job right there, Frankie, also. Yep, we would know it has to be less than 68. You're not meant to figure it out perfectly if you're using the empirical rule, but you should have a guess. Now, the area greater than 1.3, we can do the same thing for. Now, before we look at the answer, let's look at the picture. Outside the absolute value of 1.3. So that's the outside the absolute, as in the absolute value of z has to be greater than 1.3. So a negative number would have a higher absolute value than 1.3, as would a positive number. So it's going to be this one right here, which is the last one. Now, we know outside of -1 and 1 is 32% because of our 68 in the middle. I'll show the picture again. Actually, we might have our mega picture up right now. Do we have the really awesome picture? Where's that really awesome picture? Might not have it. I thought we brought it over here yesterday. There it is. Outside of 1 and -1 is 16% on either side, and outside of 2 and -2 is 5%. Now, this is our mega picture. We practice drawing this, and you can draw this when you start taking the exam. This is a much simpler version right here, but being able to draw this is very key, and we showed in class that if you draw this out, you're going to have more success than trying to do it without a drawing. So the more you draw it out, the better you can practice. We can take a good guess and say that this is probably about 18% or 18.5%, I say. Let's put in the numbers right here and find out exactly how much it is. So this is exactly how much it is. I said 18.5 and it's 19.36. Close. Not too close though. Probably wouldn't have gotten it. And that's how we do this question right here. Remember, this is the first, second, third, and fourth question as you go down. So that's a little bit of a hint right there for that one. When you do this question, it goes in order from first, second right there, third, and fourth. But don't just do it by, that is how you do it. But this question right here, make sure you understand what you're seeing and then kind of understand a guesstimate of what the answers would be. And the better you can kind of guesstimate it, the better you will do on these questions and the more it makes sense for the test. Let's hop back here to the next question. Let's do it. We have like 3 more questions lined up, but put your questions in, trying to rapid fire some questions today. Thank you so much. We had a little bit shorter office hours this morning, had a meeting, great meeting this morning. And if you have questions, let me know. Next question, we did John's question. Tiffany has one. We'll do Hannah's then Tiffany's. Hannah says, can you help me with the Chapter 5 Part 2 homework question, the cutoff values for the highest 10%? That might be the next one. The cutoff values for the highest 10%. Let's go check that out. The highest 10%. So this is my Stat 201, Chapter 5, Homework 2. Awesome, John. We're going to do a very similar thing here. We got the next question coming right up. Chapter 5, Homework 2, Part 4. Let's check it out. So this one's very similar, but this time we're given what's on the curve. So help Brian out. This time we're not given values on the curve. We're given what? So we're using the David M. Lane applet, and we're not given values anymore. We have to find the value. We have to find the value from on the curve. We have to find the value from a what on the curve. So it's asking us, what is the value? It's saying like, what is the cutoff weight? What is the value? That's what it means by value. It's like steers have weights. Steers have a certain weight. Steers' weights are normally distributed. So we need to put a mean at the center. Percents, Hannah, great answer right there. These are percentiles. They're areas on the curve, and percent of the curve needs to be shaded. We can zoom in a little bit better on this one. So it's a percent on the curve. And with this, you know what I might do? Go one down and do this. Then I can stay on the screen, I bet. U-bot behind us right here, always behind us. Oh, we're going to be able to stay? Why is it doing that? I don't know. Trying to get so I can exist. There we go. Now I can be on the screen with it. Okay. So with this right here, you'll notice we need to put in the mean and the standard deviation. But when do you use this one up here and when do you use this one down here? This one is going to get us an area, which is a percent from a value. Like if we say, what are the weights of steer? What percent of steers have a weight between this and this? Then it'll give us the percent. This one will give us where is the top 10% of steers. Dun, dun, dun. But we first need to give the context, which is the mean, the center of the curve. First value is the mean, and the second value is the standard deviation. If you notice, these numbers here change to be the mean, which is the center of the curve, and then the standard deviation is going up 1, 2, 3, and down 1, 2, 3. If you are drawing this for your test, it's very important, in my opinion, to always put the what's below these. Fill it in for 50 points. When you do this on your test, it's always important to put the what's below here. What does Brian always put when he's working his test questions? Which then, if someone said, what is the what of a steer that weighs 980? I'd say, well, it's basically this. Probably a little bit more than, or a little bit less than this. I always put my what's below it. Always put my z-scores right there. Boom. Guesstimate for me the z-score of a steer that weighs 980. Don't figure it out. I just want you to guesstimate it. I'm going to solve the z-score for a steer that weighs 980 right now, and I just want you to guess it. I want you to guess it in the chat before I hit enter. I want you to guess the z-score. Don't solve it. I want you to guess it looking at this. So I want you to guess the z-score of a steer weighing 980, and I want you to just take a guess of it. Take a guess. What is the z-score of a steer that weighs 980? Don't solve it. Don't solve it. I'm going to solve it. Don't solve it. I want you to guess it. Someone's going to give such a great guess. Wish they could. What do people think? I'll give a hint. Very close, John. I'll take that. A little bit less than that, right? It's going to be right about there-ish. So when you look at this right here, it's a little bit less than -2. And John, that was close enough. Great job, John, right there. Great job, Hannah, right there. Does that make sense? If you draw this out, you can probably figure out some z-scores pretty quickly because you're like, well, a little bit less than -2. So John and Hannah right there, great answers. So we can get a better understanding the more we use this graph and see what's going on. We want to find the highest 10% of steers. The highest 10% of steers would be known as the what percentile. Be very careful. So I'm asking a lot of in-depth questions right now. The highest 10% of steers would be the whatth percentile. Percentiles go from left to right. Like right now, I'm showing the 97.5th percentile because only 2.5% is above here. Hannah, excellent work right there in the chat. It's the 90th percentile, which means this is the 90th percentile. Now, it's worth noting, and I'll bring up another one, if we were to be over here and we were to do the question like this, we can get the same answer by putting in 10%. Oh, I'm not on the right side of it. If we go to 10%, we can do the highest 10%, and that is the highest 10%, where here is the 90th percentile, which is the bottom 90%. Does this make sense right here? And Roger and everybody, 50 points. Thank you for participating in this great stuff. Does this make sense how this is the top 10%, which is the same as the 90th percentile? Look how the numbers are identical. It just depends. Now, here's where things get tricky. Is if I were to do this right here and do the middle 80, this is where we trick people on the test. Think about this. If 80% is in the center, what is one of these white areas worth? Just one of them. What is one of these white areas worth? If 80 is in the center, what is one of these white areas worth? Just one of them. Because 80 is in the middle right now. That's what that's telling you right here. It says 80% is shaded in the center. So if 80% is in the center, then what is one of those white areas worth right there? One of those white areas would be worth what? 10%. So wait a minute. That would make this up here the top 10% again. So that would be the top 10%. So guess what? That number right there is this number here. And that's one of the many ways you could see things on the test. There's so many ways to display these graphics, but just understanding what you're seeing and then marking the graphics is key. From here, we should be on the downhill on this problem, I hope, because now what number do you want me to type into here? We want to find the lowest 20%. So tell me what number to type. Pretend you're here and you're going to solve my problem for me. What are you going to type to solve my problem right now? I want the lowest 20%. So I want to find the lowest 20% of steal rates, which should be on the left side of the curve. When we look at our answer, we want to be like, okay, that's on the left side because that's the lowest 20% of steal rates. We don't want the top 20%. There's only two numbers to pick between. Let's see what people pick. Everyone's like, I don't want to put it. So we just put in for this. Hannah, good answer right there. Hannah, 100 points, taking the shot. Perfect shot right there. So we want to find the lowest 20%. So how much of the curve do we want to shade? Don't go too out there. If we want to find the lowest 20%, we want to shade what percent of the curve? I promise I'm not trying to trick you. Not trying to trick you with this. Not a trick question. We want to find the lowest 20% of the curve. So we want to shade how much of the curve? Which is what we put into area, which is area is how much of the curve we shade. So to find the lowest 20%, I should put in what in this number block right here? To find the lowest 20%. And then it'll shade that portion of the curve. Yep. 0.20. There we go. And should I use above or below? Which of these? And so it won't be negative. It'll always be an amount. It'll always be, does that make sense? It'll always be 0 to 1. It'll always be like a percent as a decimal. Should I do above or below? Which of these is the lowest? Is it below? Is that the lowest 20%? Or is it above? Great job, Hannah, right there. Excellent work. Great job. That's going to be it right there. That's the lowest. Does that make sense? Just make sure it visually makes sense. Like that's the lowest 20%. Make sure it visually makes sense when you look at it and be like, aha, that's the lowest 20% right there. So which of these buttons do you think I should pick for the middle 40%? Which of these do you think I should pick for the middle 40%? Which of these looks like a middle? Which of these looks like a middle sort of area being shaded? Which of these looks like a middle area being shaded? Like if I shade a middle between, that's going to be that. So what should I change now? Just say, hey, Brian, change this to this. Because right now I'm showing you the middle 20%. That's the middle 20% of the curve. I could show you the middle 68%, and that's going to go to 1 standard deviation, right? Middle 95% goes to 2 standard deviations. Middle 99.7. So what should you think I should put in here? That goes, it's hard to see, but that goes to 3 standard deviations right there. What do you think I should put? What the middle 40%? Change the area to 40. Yes, Kayla, is it making more sense how to use this right now? And here's our numbers. We're going to round here to 1 decimal. And yeah, I think this, after you use it a few times, it starts to make a lot more sense. And some people are like, oh, I want my Z-tables. No Z-tables. Z-tables bad. Is this one making a lot more sense? How do people feel about this question right here? How are we looking on it? A lot better, makes a lot more sense. How to do this one here. Understand what the graphic is showing you, because it's showing you where that would be. Like if you ask, where's the bottom 20% at? Where's the top 10% at? And be careful, remember the top 10% is the 90th percentile. Awesome, Hannah. Thank you so much. Hannah, some 50 points out there. Appreciate it. Just keep asking those questions. Just be like, I'm stuck on this. Doesn't make sense. Did you get it complete? Did you get your chapter 5 done? Start early, ask questions. That's how we roll. That's how we get things solved. Love it. I think, Tiffany, we got your question coming up right here. I think it's time for Tiffany's question. And then I see a few after. I'll see here. Roderick, your question is next after this. Tiffany's got a question. Tiffany's second question is, my second question is, on chapter 6, can we do another problem like the one we're doing Office Hours with the ceramic factory? Yeah. Is there one like that, Tiffany? I'll do another chapter 6. Do you want to do another version of the ceramic one? So Tiffany, do you just want to do another chapter 6 or another ceramic version? I think this morning you want to do another version of the ceramic, right? Do you want to redo the ceramic or do a different one? I'll let Tiffany decide right here. Redo ceramic or do a different one? On question 3, is it on the homework? Brendan, so we can swing back and do that again. Check it out. Hey, Zayed, good to see you here. I got a homework on the 100 on homework. The version of the one question. Yep, we'll do a different version right here. Okay, got it. Okay, let me do a different version of it. Okay, here we go. Did you have it? We're doing it tonight. We're doing it tonight. I'll send out another announcement. We're doing it tonight. Tonight. I need to send out an announcement for that. So check out the activity night tonight. It's one of the upcoming streams right here, as long as I'm not too burnt out. I usually do it on Wednesday, but yesterday was busy. No worries, Brendan. Check out, it's the second question we did. So look about 10 minutes into the video. If it doesn't make sense, let me know. Here we go. We got a version coming up right here. Let's check it out. Chapter 6 right here with the ceramics problem is chapter 6, ceramics problem. And let's take a look at what we have right here. So looking at this, let's review. This is going to be very important. What graphic is this up at the top right here? What graphic is this up at the top? What kind of graphic am I showing you? Review. This is review. We literally were going over this in 320 today. All classes should know this. What kind of graphic is this? What kind of graphic is that? Help Brian out. It looks like we have batch number, which is quantitative. It looks like we have number of broken pieces, which is quantitative. So what kind of graphic is that? 2 quantitative variables makes a what? 2 quantitative variables, good review. 2 quantitative variables makes a what? 2 quantitative variables will be a what sort of display? Hints on the screen. I'm not blocking the right answer. 2 quantitative variables makes a what? So use the graphic on the screen to be like, okay, 2 quantitative variables makes a... I can say the answer, but you got to practice. You got to be like, okay, 2 quantitative variables makes a this. What kind of graphic is that? Scatterplot, great job, Tiffany, right there. Some points in the chat. And then down here below, what do we have below? We have a bunch of whats. We're going to have to pick which one is the right what for it. We're going to have to pick which one is the right what for it. Now, this is univariate quantitative. These are only showing us one variable, the number of broken pieces. So what are we seeing right here? These are all different whatses. It kind of tells you over there. These are all different what? Univariate quantitative with shape, center, spread. So these are all going to be described by shape, center, spread. Histograms, great job, Tiffany. So we have here histograms, different histograms. Scatter plots help us understand strength, direction, form, and unusual features. We'll be talking about that a lot Monday next week. Histograms help us understand the what. I'll throw out 100 points. This is a big review for things we've already learned. Histograms are going to help us see the what. I think Tiffany might be right on that one. I'll show you how to get that answer in a second. Histograms are going to help us analyze the shape, and then where the middle is, and then how far it is what out. So remember, when you look at univariate quantitative, we want to look at the shape, which is how it looks, and then we want to see where the middle of it is, which is the what. Boom, right there, Kayla, you got it. So that is for when we look at, great job, Frankie, that is for histograms. Next Monday, we're going to be talking about strength, direction, form, unusual features. So you're getting a head start by knowing scatter plots have strength, which this is strong, it's positive, it's linear, and there's no outliers. That was the strength, direction, form, and unusual features of this scatter plot. More on that on Monday. A good preview of the future. So the way we know which histogram is the right answer is we need to look at only the y variable. So we need to check this out by going right here and saying, how many batches have 0 broken pieces? 1, 2, 3, 4. How many batches have 1 broken pieces? 1, 2, 3. Now you might be noticing I'm not looking at this bottom variable down here. Let me ask The Rock what he thinks about this bottom variable.
It doesn't matter.
Ooh, he's a little saying this variable doesn't matter down here. I'm not looking at the scatter plot right now. I'm trying to understand the distribution of broken pieces and understanding how many batches have 2 broken pieces. And there are 4 batches that have, or 3 batches that have, right here, 2 broken pieces. 3 batches that have 1 broken piece. 4 batches that have 0 broken pieces. 4, 3, 3, 4. That's 4, 3, 3, 4, 3, 3, 4. And right here we see 4, 3, 3, 4, 3, 3, 4, because that's the height of the bar over there. So this is the histogram, and you have to look at, great job, Tiffany, excellent work, following along perfectly, yep. And so now we're getting into the idea of describe the shape, describe the distribution of the histogram. Now, what does uniform mean? Practice, because people forget this one, it is uniform. But break down the word uniform so you'll be like, oh, it is this, it is one this. So uniform, when you see uniform, which this is not unimodal, which means one mode, it's uniform. So it means it's one form. It's uniform. It's just flat like one form. It's mostly uniform. This would not be a mode, a mode, a mode. It's not trimodal. It's mostly uniform. It's flat. What features is more apparent in the histogram than the scatter plot? So the histogram is going to show us the shape of it. So remember, shape, center, spread is a measure of uniformity, which is part of shape. That's going to tell us if it's a uniform distribution. So, and symmetric, I like that right there. It is symmetric. You are correct. So I like to think as you draw a line over the top, exactly, does the line, is it kind of flat? Is it pretty flat? Pretty flat, it's pretty uniform. And then what aspect of the company's problem is more apparent in the scatter plot? So if I say this goes up, I'm talking about the what of it. Good review. If I say this goes upwards, Brian's talking about the what am I talking about of this? Because it is positive. Brian, remember the 4 keywords? Strength, direction, form, unusual features. That's how we'll talk about this on Monday. So you're getting a good head start on Monday's lecture by knowing those 4 keywords. Strength, direction, form, unusual features. So Brian has just told you the what of this. Positive direction. Great answer, Tiffany, right there. It's a positive direction. And that's what we're pointing out down here, that there is a positive, that's the direction, somewhat linear, that's the form, relationship between this. Yes, we got it. Another one bites the dust. We're doing it strong here. We got this on Stat 201. Some 80s series music right here. I think Roderick, thank you so much, Roderick, for hanging out. Does that make more sense, Tiffany? Great job, Tiffany. Excellent work. Tiffany, and I will say this, like working ahead, which you're doing so excellently, is such a great way to learn the topics. So shout outs to Tiffany right there, because that way when you're in class, it's like, oh, wait, I was doing a homework on this. This makes more sense. You have to hear things 2 or 3 times. I always compare it to playing piano. You don't play a song one time and you learn the song. You have to play a song multiple times. You sit down and practice songs you already know how to play just to get it down. So you don't play a song one time and say, I did it. I played that song. I'm done. You practice. That's why when we code things multiple times. I know. Great job, Tiffany. I'm excited. Keep studying hard for that test. Exactly. And then just the terms, like you'd be like, oh, when we talk about quantitative relationships, we'll look at scatter plots and look at the strength, direction, form, and unusual features in the scatter plot. The conditions are 2 quantitative variables, straight enough, and no outliers. Q, straight enough, no outliers, plot doesn't thicken. More on that later on. And then we just get to practice in class and just make sure we got it down. I'm throwing out 100 points. So much positivity today in the chat. We love it. Did you happen to cover any questions on the Canvas content quiz? We could do one of those, Matthew, if you want. We have done some already. I think we have 2 more questions lined up, but we're going about 5-10 minutes a question right now. So throw a question you want, say, hey, can you do this one? And we'll be doing it here soon enough. And if you have to leave, it'll be in the video. So Kayla's question was, we do try to circle back. If someone has a question we already done, we do circle back eventually. Kayla's question was, Roger's question was, good afternoon. I am on class. However, I'm in another class. Can you go over number 2 on homework 3? Number 2, homework 3, 474. Okay, let's go look at number 2 for 474, homework 3. Let's go check it out. That's pretty good. I do like Big Bang Theory. I give it a it's okay out of awesome. Big Bang Theory is pretty good. I watched some of it. I know some little penny. I know a little. Discretization is not a word. It is. Discretizing numerical values. Can you do another version of yeah, we could. Frankie's killing me in the chat. Turning them into categorical variables is a common task in data mining. Okay, so what is discretization? Discretization is when you make a variable discrete. Discretize. So what is a common variable you often see discretized? And I hate it. Age groups. Age groups is a discretization of age. So Brian is in the 30 to 40 age group. At the very low end of it, might I say. But this is making it discrete, turning it into categories. So, and this is not a bad thing for 201, because we're taking a what variable, we're taking a quantitative variable, numeric values, and then we're turning those values into categoricals. So literally, if you look at this stuff, if you're in 201, you're like, gosh, this stuff looks insane. It's the same thing we've been doing. We're just saying, let's take some numeric values and turn them into groups, turn them into categories. That's what discretization means. Make something discrete into discrete groups. And later, of course, we'll use predictive modeling on this, use the junk data set in red class, and to figure out if things have exclamations. Okay. Use if-else to create a categorical variable called has money that takes the values yes when the money column of junk is greater than 0 and no when the money column is equal to 0. Provide a summary. Okay. So once again, I'm not going to do the exact same thing. Oh yeah, we can do that right here. Mr. On the chemist contribution, everybody. Yeah, feel free, Andrea. Feel free to put any question you want in the chat. Be like, hey Brian, can you do this one? And drop it in, and we'll start working on it. So what I want to do is I want to work with a different data set. And so I'm pulling up Survey 10 because everyone loves Survey 10. And I want to see if someone has tattoos. So let's see if someone has a tattoo. So what we need to do, and we use the if-else. Oh, if-else is so amazing. What if-else does is it takes a logical vector. And wherever there is a true, it'll return the true statement. And wherever there's a false, it'll return the false statement. That's how an if-else works. So this right here is the code that runs. So I will throw 200 points. If someone can tell me in the chat, let me make it a little tougher. Or let's do this. What will this run right here? Who knows? And sorry if you say I don't know, that's a fine answer. Who knows what this will run in the chat right now? So let me make this very clear. This is the first thing. So this is what's running right here. And then this is how it operates. This is what it'll do if there's a true statement. This is what it'll do if there's a false statement. So this is what it'll do if it's a true. This is what it'll do if it's a false. So what will this return? I bet you someone who hasn't coded much will be like, I think I see it. Think about what this did. So what will this return right here? This is what it's evaluating. That's all by itself. That's in its own little thing here. It's in its own little world. Hey, Trevor, good to see you here. So what will this code return? 20 points, Trevor, right there in the chat. What will this code return? So the if-else takes a logical vector. This is what's called a logical vector. False, true, false. And wherever there's a true, this code will run. And wherever there's a false, this code will run. So look at where the falses are at. Look at where the trues are at. And think about what will be the output. Who knows for 200 points? 200 crazy points on the line right here. Very good understanding. Yo, Jacob, good to see you in the chat. What will this code return? I'll give it a second longer. Let's put 30 seconds on the clock. I'll give it with the answer if no one gets it. But Rachel, good to see you here. Drop questions if you have them. We're going to do a little bit of this right here. What will this code return? So I'll explain once again. Kayla right there. Kayla, I'm throwing 300 points. Kayla, 201 student, getting the question for the senior level statistics class. It is going to return technically quote B, quote A, quote B. You got it right there. That's how it's working. You have to if you start to read, be like, okay, it's just wherever there is a true or false, right in the nick of time right there. Kayla, amazing work. Yep, you're doing senior level statistics right here, or doing senior level coding practice right here. So think about this. Let's go here and let's see if someone has a tattoo. Now, I'll write the code that does that. It's similar to what they're doing now. We're going to go here to see if someone has a tattoo. And this survey, and I'm going to start 10 and tattoos. Does it make sense that this is just the tattoos people have? Oh, no, that's, I wanted you to. That's why I gave 300 points. I was very impressed. Yeah, we can do sheer strength. You got it. No, Kayla, I wanted you to. I was happy that a 201 student answered it. If I can explain it to a 201 student, I expect my 474 students to get it. So great job, Kayla. They'll probably be watching this video later. I'm very proud of you. So does this make sense that these are just how many tattoos people have? Are you following me with this? I am looking at the tattoos people have. Like this person right here has no tattoos. This person has one. These are people reporting I have 0 tattoos. I have 1 tattoo. I have 1 tattoo. I have 1 tattoo. I have 1 tattoo. Then I'm going to run a test right here to see if their tattoos are equal to 0. I'm just only looking at this code. So it's going to tell me true for this person. It's going to say, yes, this person has 0 tattoos. It's going to tell me false for this person, that person does not have 0 tattoos. So remember that those numbers we just saw? So right here, we see true, false, false, false. All the positivity worth another 50 points in the chat. So we see, do they have 0 tattoos? So let's go here and say no tattoos. And let's say here tattoos. Because now if it's true that they have 0 tattoos, it will replace this with whether or not they have tattoos. Let's store this into X. Sorry, everyone's like, what are you doing? Storing it into X. We're just calling it something. And then we're going to overwrite X with a factor right here. And guess what we just created? We created a categorical variable. We discretized. So we made discrete groups. And we could even go to our data frame now. And we could say has tattoo. And go here and store X into this. And guess what? On our data set, we now have a variable called has tattoo. I know it went a little quickly at the end right there, but it's the if else that's going to be the tough part. For the students in 474, they probably know how to use the factor, I hope. But I have now coded a variable called has tattoo. So you can see right here, this person has no tattoos, and we could check their value for their tattoos, wherever their tattoos are at. There's their tattoos of 0. And you can see right here, if we sort this, the person with 6 tattoos has a tattoo. So they have tattoos. So it's either tattoo, has no tattoo, or I called it tattoos. Oh, yeah, there we go. Sure. We could rechange that. I could call it has tattoo. Has tattoo. Yeah. And then we could recode it like this. So now we've just recoded the name of that variable to has tattoo. So you can see who has tattoos and who has no tattoos. Has a tattoo, has no tattoos. So this is one of the things about coding that's so nice, is you can just recode things pretty quickly. And this is how these problems right here work. So don't worry, especially 201, I'm so proud of you right there. But that's one of the cool things about coding and how we can do these things. These other questions here are going to be very similar with the if else's, and the key syntax right here is to understand how to use the if else, that it takes a logical vector. And so once again, this is going to return trues and falses. And then whenever there's a true statement, it'll use this code. Wherever there's a false statement, it'll use this code. And I'm looking at people's tattoos to see if they have 0 tattoos. So if they have 0 tattoos, it'll say no tattoos. If they do not have 0 tattoos, it'll say has tattoo. That's got it. Really good stuff right there. I hope that helps out 474 good bits, because that's very similar to what you're doing. Very similar stuff right there. Who had the next question? Put some 80s serious music on right here. Who had the next question? Let's see. Does anyone remember chapter 6, scatter plots? Did you happen to cover Matthew wants Canvas content? So Matthew, did you have a specific Canvas content one? Because we haven't, Matthew's got the first one right there. And then Tiffany, it looks like. So Matthew, then Tiffany. And who else? I think Matthew, if they put theirs. Oh, Rivet Strength. I'm going to do Rivet Strength, then yours, Tiffany. And if you're here with the Canvas content, Matthew, let me know. So we're going to do Trevor's Rivet Strength one for Chapter 5. Let's go do the Rivet Strength. That's a tricky one because it tricks you with the graphic. Not that I've ever worked that problem. That's part 2, right? And then, Tiffany, we're going to do the scatter plots next after that. So let's go right here. And then Matthew, if you can hear me. Matthew, can you hear me? If you can, we will do the Rivet Strength one. Not that we'll do the Canvas content. Rivet Strength coming up, Chapter 5, Part 2. I need it right here. On Stat Tool 1. Chilling out. Let's do this. A company with Rivet Strength. Let's do this. Chapter 5, Part 2, Rivet Strength Company. Let's do this. So this one's really tricky for one main reason. Please notice that with these graphics, how many standard deviations are we going up and down? Notice right here, how many standard deviations are we going up and down? This is the trick that people fall into. Is they get this part and they say, oh my gosh, I can't believe, what did I do? What do you notice right here if I put some z-scores below this? They're trying to trick you. We don't like my Pearson. Not today, my Pearson. Not this question ever tricked me. 2, Kayla, you're right. 2 standard deviations. The reason we know this is because it's 95. If it was 1 standard deviation, it'd be plus or minus 1 and 68 in the curve. So yes, if we're going 50, great job right there. 50 points right there. Great answers in the chat. If we're going 50, which I think we are most of the time, then we want it to look like this. Also make sure your numbers follow the right pattern. So that's the common mistake that happens. Probably the most common one. Is the standard deviation 50? It is the mean of 750. So the correct one, you see this looks right, but it's 2 standard deviations. This one's too small. So it's going to be this one right here. That's the most tricky part of this. And down here we get to, would it be safe to use 700? Now, I just drew it out a second ago. 700 has a z-score of what? So go ahead and answer it in the chat. 700 has a z-score of what? Here's a hint. 700 has a z-score of what? So what is the z-score of 700? Jacob, 100 points in the chat also. Congratulations, Jacob. Proud of you, man. Jacob, I'm gonna ask. Hang out for a half second, Jacob. I want to ask a question. I'm gonna finish this question off right here, pretty strong here. So it's 700 is gonna be right there, and then if we have between here 68%, then outside of here would be 32 total, which puts 16 on either side. So below here is 16%. So this would be the area below this portion is 16%. Make sure to follow your graphic. So whoa, don't cheat me out of that answer. So that's the bottom 16%. What percent of rivets are going to fall below 850? That's a tough one. It's not that bad. Below 850, we'll erase this down. Then if Jacob is still here, I want to ask him such a question because I'm so proud. That's awesome. This is one of the harder ones. This is about the hardest it gets in the class. Like if you can get an A on these, you're probably pretty good for the rest of the semester. I mean, it's just different material, but difficulty level doesn't really go up. Outside of here is 2.5 above, and that's pretty much the best way to answer it because below here is 97.5. You'd go through this and then through the remaining 2.5 on the bottom to get your 97.5 right there. But I think it's a bit easier if you think of 2.5 above, 97.5. Jacob, great job. And Jacob, let me ask you this. We're going to go back to the main screen here. We're going to take another question. Tiffany, your question is next. Jacob, real quick question. When we covered this yesterday in class, stop changing my answer. Whee! Jacob, when we covered this yesterday in class, what difficulty level out of 10 did this feel like? And I totally understand this. This is a tougher chapter. Yesterday in class, 1 to 10, 10 being impossible, 1 being a joke. I'm hoping to hear a big shift in the difficulty with the second question I asked. Yesterday in class, 1 to 10, how difficult was this? And this is what I hope everyone can see. I hope people start to feel this way about this chapter. Because it's one of the ones you can beat. You can win this chapter. You can get it. You can be like, I get what's going on with these graphics. I get how to read them. I know what the z-scores are. I know what the percentiles are. You're welcome, Trevor. Excellent work. Quote 104. How knows it? Whose quote it is. A lot of people think this chapter is more like I'd say, Mubad, you kill me, man. A lot of people feel like this chapter is more like a 7, 8, or 9 difficulty. But I think after you do a bunch of the work in it, after you like work the problems, it drops dramatically. It can become one of the easier chapters, but the hardest part about it is very few people have worked problems like this. It's like learning how to play a new instrument. Exactly. So let everyone know it. If you got someone you know who's struggling, if they're in a group me, if they're in a Discord, and they say, I don't get this, say, hey, check out this video, watch this walkthrough, try solving this, let me know where you're stuck, help each other out, because this chapter gets a lot easier. It's really tough. And I was trying to do as many examples as I could yesterday. And I feel like the afternoon class got really stuck. I felt so bad at the end. We had like 15 minutes to go and everyone's like, I'm lost. And that's when I just feel the pain. I'm like, no! I'm like, did I not? 3 out of 10, just because I was a little confused on how the question was worded. I figured out, awesome. Hopefully we make this a lot easier. That's our goal. And I want things to be easy. I want the concepts to make sense. And I felt bad yesterday for the afternoon class. I was like, I have failed you. I did not make this understandable. But don't let that discourage you. What do you do when you fall down? You get up. You fight harder. That's what we do. I don't let it discourage me when I have a day where I feel like my teaching's not on point. Not that I've ever not had great teaching. Every day's great teaching. I wish. Tiffany's question is, let me see here. Tiffany, you wanted more versions of the graphics, right? Is it more versions of the graphics for chapter 6? More versions of the graphics. I like these ones a lot. We'll knock out a lot of them right here. Let's do more versions of knowing what the correlation is. Let's check out more versions of correlations for chapter 6, knowing the values of correlation. Here we go. It's complete. Open floor on questions after this reminder, so check it out. Drop a question in the chat. I think we're open floor on questions. If you want some Canvas content or whatever you like, drop it in the chat. Let's do it. Which of these scatter plots show no? Oh, that one. Oh, yeah, that one. This is the tough. I say this is one of the toughest ones. Okay. Here we go with one of the toughest problems probably on this. You have to be very careful. This question right here, right? Now, when you look at this, I would immediately start by describing these. We have, with this, a few words we use. What are our 4 words? I'm going to help you out and give you 3 of the 4. So tell me the last one. Direction, form, unusual features. What is the first word for describing bivariate quantitative relationships? Not mosaic plots. What is the first word for describing bivariate quantitative relationships? The first word for describing bivariate quantitative relationships is what? Strength, which is how tight it is around the form. Great job right there. Some points in the chat. Strength. This differs from univariate, which is going to be shape, center, spread. That's univariate stuff. Great job, Kayla and Tiffany right there. Excellent work. Good practice. And so when we talk about the first one, just listen to how we describe this. This one is super weak because it looks like a 0. That's what the correlation is going to be very close to. It doesn't really have a direction. Its form is like no form, and it doesn't have unusual features. That'd be outliers. Like an unusual feature would be when you have a stream of points going up and then there's some outlier down here. Form is going to be if it's linear or not, and both of these here are linear, so these have linear forms, but this one's positive, this one's negative, this one's like super strong, and this one's moderately strong. So now, and none of them have outliers. Is it E? So which of these have no association? That is correct. Graphic 1 has no association. Which of the scatter plots show a negative association? A, B, C, D, or F? Which of these show a negative? So which of these show a negative? So we've kind of made our cheat sheet now to help us out. Which of these show a negative association? You got this. We got this. Now that we've written our cheat sheet down and we've got it described, we've drawn it out and we can figure out which of these show a negative. Yep, graphic 2. So it's a, yeah, oh, great job. I actually was, yeah, wow, that's so confusing, isn't it, the way they do that? Be very careful. It is confusing. Which of these show a linear association? A, B, C, D, E, or F? Great job, Mohammed and Kayla. Excellent work. Which of these... And then... I think you're right, Mohammed, right? And then which of these show a... Hey, Parker, good to see you here. Which of these show a linear association? I've got my cheat sheet up. That's the form it's asking about. It's asking us about the form, and it wants to know which of these are well described by a line. It's saying which of these are well described by a line. Great job, Tiffany. Yep. You got it. I hate the way it keeps changing that on me. I'm going to make an error because I'm going to misclick. Which of these scatter plots show a weak or moderately strong? So look at my words. Don't overthink it. Which of these show... Ah, that's awesome. You're at high school. Are you in high school, Mohammed? That's awesome. Well, if you want to learn stats, you're in the right spot. Correlation has 4 features to it. The strength of the correlation, the direction of the correlation, the form of the correlation, and unusual features, which would be like an outlier. None of these have unusual features. Well, that's awesome. Glad to have you here. Feel free to practice up your stats knowledge. So which of these shows a moderately strong? The answer is D, and that leaves here, this one is super strong. The strength of it is how tight it is around the form. We'll do another version. I'll do it a little bit quicker here. But great work. Did we get them all right? Not today, my Pearson. Not today. Like that right here. You know what? This goes out to Muhammad right here. This is one of my favorite things right here. Let's do it. Shout out to Muhammad right here. It's close enough to evening. Let's head back. Yeah, Kayla. Great job noticing that right there, Kayla. 50 points. I like that. I don't know. Any excuse I have to do that for a new person. I just want to hit that button. So let's do one more version of this because this is a good one. It's a good one. It's a tough one. I want to do one that's a little bit different. Ooh. Oh, I bet you I might get one wrong right here. Brian's going to get one wrong at the end because he's a little bit iffy on it. This is going to be bad. Okay, you ready? Which of these show no association? It's graphic 3. That's no association. Which of these show a negative? It's graphic 2. That's the only one that goes generally downward. Which of these show a linear association? It's only graphic 2 again. That's the only one that's well described by a line. Which of these show a moderate or weak association? That's graphic 2, because this one looks to be a bit stronger. Woo! Scaring myself there. Scaring myself. That's tricky. Scared, worried. Similar enough to the last one we just did. Trying to do one more, maybe. This is a good one. It's a good another one. Which of these show no association? This one's non-linear, but it is associated. It's just non-linear. So which shows no association? They all have some sort of association. UT alumni class of 26. Yay, Dylan! Still awesome, Dylan, man. See, I just did the Smash Bros thing, but we got a bunch of new stuff, Dylan. We've even got Skeletor these days. He's not happy about it, but he's here. He's there in the corner. So which of these... Good to see you, Dylan. 100 points for Dylan showing up. Which scatter plot shows a negative association? This one goes downward, so scatter plot number 2. Which scatter plot shows a linear association? Thank you so much for still being subscribed. You can unsubscribe at any point, but I am honored by that. Don't unsubscribe. I like it. I love it. I might watch my subscriber count go up and pat myself on the back. So thank you, Dylan. I'm going to go on a limb here. I'm just making Dylan a mod. Which scatter plot shows a weak or moderately strong association? So these... I'm going to go out on a limb and say it's D. That's a little bit weaker because it's a little bit less tight than these. These are tighter. That's the strongest. So these are going to be the strongest. I am a little worried. Brian's went 2 for 2. Can Brian go 3 for 3? Not today, my Pearson. Not today, my Pearson. We're just going all the memes today. Not today. Chapter 5, Part 2, IQR of the cholesterol. Let's go check it out here. IQR cholesterol. We're just having some fun here today. IQR cholesterol coming up right here. Let's do this. Yeah, let's do it. Let's check out the IQR of those cholesterols right here. Tiffany, great questions right there. That's a tough one. That if I say it's tough, that means I've made mistakes on it. And you can ask Dylan. You can be like, yeah, Brian's been working these problems for many years. It's just easy to maybe disagree with my Pearson every once in a while because they're not perfect. Not that I'd ever make a mistake, but never, ever make mistakes. Let's go grab the IQR of the cholesterol levels. Ooh, cholesterol, no good. So let's check it out. Put on a little chill music right here. I like it. Dylan's probably seen this change a lot over time, like just the channel and everything, to where we're live streaming a lot right now. It's good stuff. Did I miss it? I will find this cholesterol level problem. Oh, found it. Let's go check it out. Cholesterol level problem for Stat 201. Let's check it out. Chapter 5, Part 2. Here we go. Okay. Hope Dylan didn't unsubscribe. So here we are. The cholesterol levels of an adult can be described with a model that is normally distributed with a mean of 189 and a standard deviation of 27. When you see the mean, that means you put it at the center. When you see the standard deviation, that means you go up by that many units each time. And that's where we're going to see the differences right here, where this one's little too little. That's not 27. 189 plus 27, not 203. This one's a little bit too much. 189 plus 27, not right math. But this one is just right. 189 plus 27 is 216. You should check all the numbers right here, but make sure your numbers are working out because different problems try to trick you in different ways. Great job right there. Nice work right there. Tiffany, another 100 points in the chat. Congrats right there for that 100. So this problem right here is going to have us give exact numbers. We can get estimates from the graphic, but we're going to use the David M. Lane applet. Mubot, tell us about that David M. Lane applet. How you doing today, Mubot?
The David M. Lane applet is where you go to use answers. You will not have it during the test. You might have pictures on the test of the David M. Lane applet. It will look something like this. This is what a test question could look like. Review other videos or Canvas content to find out.
Mubot, you the best. Let's go over and check out this applet. This is the David M. Lane applet right here. Once again, as Mubot said, you will not have this applet during the test, but you might have to use pictures from the applet, so knowing how to read the applet is very important. What we're going to do right here is we're going to take, and we're going to get mad at it, stay this way. We're going to go and take the mean. It might be a little small, but I'm just putting the mean right here. 189 is the center of the curve, and 27 is the standard deviation. Now, every time you use the applet, I like to change both numbers for the mean. Be careful, the second time the mean is a little bit lower. 189 and 27. And pause the video if you need. I'm just putting in the mean and the standard deviation on both curves. Now, why this is important, we'll do a little movie magic right here. Why this is important is because it might ask us questions that give us a value, or it might ask us questions that give us... My computer doesn't love me today. It might ask us questions that give us the percent. Good to go. I'd like to have it over here on the side so you can see what's going on as we solve the question. So let me disappear. So we've drawn out our curve right here. It's the same curve we have. And remember, you can draw this out yourself. We do this a lot during class. We do it a little quicker here, but you can draw out the curve and put your numbers below it. Highly suggest doing that when working any of these problems. What percent of adults do you expect to have cholesterol levels over 190? Ooh, a little bit less than what? I don't want to show you the answer. I wish it's going to be over here. But if we go to 190, I don't want to show you the answer. Does it say above 190? Yeah. It's going to be, we can almost guess this. Just look at that. This is a decent test question because someone just take a guess of this. Look at it visually. And this is the percent of adults who would expect to have cholesterol levels above 190. Just take a guess and be like, yeah, that's probably about this. Like visually, just look at it. I can't zoom out any further or you'll see the answer. But think. That's 189. That's not 190. So it's got to be a little bit what? And this is a decent test question to have multiple choice on. Because I can tell you it's very, very close to this, but a little bit less than this. So you think about how we could ask it on the test. You could see the picture, and the picture is going to give you a number. We could ask above or below this. But this is going to be a little bit less than what percent? Who knows for 50 points? Hint. Who knows? It's going to be a little bit less than what? That area right there, which will be the answer to what percent of adults do we expect to have cholesterol levels over 190, because that's what I've graphed. I've graphed above 190 on a curve with a mean of 189. Same curve right here that we're looking at here. So it's the same curve, double checking our answers. It's going to be a little bit less than what? 50. Kayla, great job right there. And look at it. It's just a little bit less than 50. So you're totally right. That's a little bit less than 50. And we're just going to paste that answer in right here. 2 decimal places. Make sure we have it in the correct spot. Now we want what percent of adults have cholesterol levels between 160 and 170. 160 to 170 is somewhere in here. That's going to be like 25%. So we go between, and we go to 160 and 170. Ooh, I was way off. It's about 10%. I should have just said 10%. 9.94, 160 and 170. Estimate the IQR. The IQR is what percent of the curve. Good, important thing to know. The IQR is what percent of the curve. The IQR is what percent of the curve. The IQR is what percent of the curve. Good things to know. It's the middle of this. The IQR is what percent of the curve. So it wants us to find the distance from Q3 to Q1, which is the 75th percentile to the 25th. Yep. Trevor, great answers. Trevor, you are right for another 50 points in the chat. It is the 50th, the middle 50%. And here we are, the 75th percentile and the 25th. Does that make sense, Trevor, right here? This is the 75th percentile. This is the 25th. And what am I doing to these two numbers right here where we have the 75th percentile? And then I have the 25th percentile. And then I get the IQR. I'm just subtracting them. It's how far apart are these two numbers. And you can see it visually right here that they're about 36.4 apart. And so this is rounded to the nearest integer. So we round right here, round to the nearest integer. Yep. Above what weight are the... Yeah, great job right there, Trevor. Some more points. Jacob, thanks for the positivity right there. Above what value is the highest 15%? Now, I want you to tell me, should I use above or below? Should I use above? I want the highest 15%. I'm going to ask 2 questions right here, good review questions. The highest 15%, is that the above or is that the below? The highest 15%. Is that the... It is the above. And then, Kayla, great work. What percentile is the highest 15%? The highest 15% is the what percentile on the curve. So think if this is the highest 15%, Kayla, some points right there. If it's the highest 15%, oh, wait, I've not completed? Oh, no. What did I not complete? Oh, check answer. The highest 15% is the what percentile. The highest 15% is the what percentile. So if you see where that answer is at, 217, watch this. The highest 15% is the 85th percentile. Great job, Mia, right there. Mia, some 50 points. Does that make sense? The highest 15% is the 85th percentile. Mia, great job. And I think it's open floor on questions. Once again, we still got like 20-ish minutes. Sometimes I end a little bit early because I teach right after this. But it's open floor on questions. So throw those questions out. Time to ask your questions. Let's see what people got. Excellent work today, everybody. Hair's starting to get a little bit longer again. Let's just let it go to my shoulders again. It's been like, what, 2 months since I got a haircut? My haircut really short. Can't do that again. I think I want pizza tonight. No, I need it healthy. Need to eat some vegetables tonight with some like beans and stuff like that. Planning out dinner right now. Go on my Pokemon walk. What questions do you have? We could do some more chapter 5 or chapter 6. My kids want tacos. Who am I to object? I agree. Never overrule tacos. We you know what? We can make burgers tonight. Adam, have a great day. Maybe I'll make like a burger with beans on it, or I'll have burgers with beans. We got this store at HEB near us. Top tier stuff. Vincent, which one do you want to do from chapter 5? Take your pick, chapter 5. What would you like to do, Vincent? We're just here talking about tacos and burgers. Burgers aren't bad for you, are they? Never overrule a 2-year-old. You're not going to win. Everett's 2 years old. My nephew Everett. I want to go see them and be the good uncle. Not that they only have one uncle, so I get to be the good uncle. Well, they only have one uncle on my side of the family. Trevor, great job. Congratulations. Some points for Trevor in the chat right here. Giving out so many points today. You have 3 kids? Awesome. It's got to be a lot. Great job. Kayla, great job working through it here. So, excellent work. That's got to be a lot right there with 3 kids. We got 2 bunnies. Whatever will be on the exam. Let's find a chapter 5 question we haven't done yet. This one's tricky. Let's go to this tricky question. Chapter 5, Large Philanthropic Organization, Chapter 5, Part 2. Kayla, you're doing a great job. Yeah, just overall, like 3 kids or just not 3 kids, you're doing an amazing job. Great job with the material. Excellent work. Proud of you. Proud of everyone right here. Chapter 5, Part 2 quiz right here. We got this right here. Large Philanthropic Organization. Which is a better summary of percent of white residents in the neighborhood, the mean or the median? It's a tricky one. Should we use the mean or the median? I don't think we need the applet right now. Should we use the mean or the median? What do you think? Look at that. Let's draw our monster man right here. Where you at, monster man? Have a good day, Trevor. Good seeing you, man. This monster man, he got like super tail. He's like being like Nessie right here in the ocean. Oh, is Nessie in the ocean? Ah, be careful. So this one is very, 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 very skewed. Very left skewed. 20 points right there. Just remember, practice right here. The median, because it's very skewed. The median is a better measure of the summary. Better measure summary because the data is skewed to the right or to the left. Left or right. No worries. Good practice. Good correction right there. Is it left or right skewed? What do you think? Left or right skewed? Is it left or right skewed? Trying to trick you. Don't worry if you got tricked. But it is left skewed. Left to the low, right to the high, whatever way the tail goes. Right to the high, left to the low, whatever the tail goes. What is a better measure of the spread, the IQR or the standard deviation? As soon as you pick median, what are you going to pick? This is a great review question. As soon as you pick median, you know that you are going with the what immediately here. Like you say, we should use the median for center, then for the spread, boom. IQR, Frankie, right there, exactly. That's just instantaneous because it's based on percentiles. So we're choosing the IQR because it's based on percentile, and median is the 50th percentile. IQR is the 25th, 75th percentile. It's a better measure because of the skew to the left. Awesome work. Great job, Vince. Another 20 points chat. From a normal model, so this is saying if the normal model applied, that's what it's saying right there. About what percent of neighborhoods should have a percent white residents within 2 standard deviations of the mean? If we use the normal model, 68, 95, 99.7. Who knows the answer to this? If we were to use the normal model, if the normal model applied, it should say, if the normal model applied here, which it does not, what would we expect? So if the normal model applied, if the normal model was the right idea, that's kind of got it. Here we go. If the normal model applied, 95, and that's what we're seeing right here, 68, 95, 99.7. This one's not that bad. Whew, here we get down to the bad ones. What percent of neighborhoods actually have 2 standard deviations above the mean, within the mean? Okay. So a standard deviation is 25-ish. The mean is 83. I guess this is not fun. Not fun anymore. Is this the data? That's that. Well, that's not going to help us that much. Class a little bit. Okay. So we need to go here. Let's do this carefully. It was 83 and 25. I'm looking at the mean and the standard deviation. 83 and 25. Nope, wrong color. I'm marking where 83 is at because that's where the mean is at. And that would go up past this if we go up 25. Actually, since it's 25, I just need to go down about 50, which is to about... Gosh, this is such... I hate this problem already. It's about to there. So that's 2 standard deviations below. That only leaves out this. How many neighborhoods were there? Because that's about 10, 8, 6, 3, and 3. So that's 12, 20. I'm looking at the heights of these bins right here. It's about 30. It's about 30 neighborhoods. This is the hardest part of this question. I've gotten it wrong before, and I'm saying not today, my Pearson. 500 donors. So 6% on the outside. No, it can't be that close to it. I hate this question. This is where we're going to make an error. This is where my Pearson wants us to eyeball this question. If you get this question, you think it's B? I mean, it feels like B, right? It feels like B. You see, here's the thing. It feels like B. If you get it wrong, Frankie, just tell me. I'll fix it. Explain the problem using this. Strong left skew. Vincent, 100 points. Give me that confidence right there. You're right. Brian showed you what it had to be. Brian said, here's my estimate. That's the area outside of. 1 minus that is this. That's what I estimated it to be. And look at that. Vincent giving me that confidence right there to hit that button and take that answer and say, not today, my Pearson. Not today. You're not tricking me. My Pearson trying to trick us with those questions. I don't like that. I don't like that portion. Now, I did estimate it. That's what I estimated. I should just said I'm going with what I've done, but I know this question has burned me before. So my estimate did show a number between that. Not today, my Pearson. Another 20 points right there. Tricky question. Wouldn't love that on a test. It's just one of those, like, it kind of snuck through because it had some good parts. Yep, keep us confidence. Do it. Just, we haven't gotten anything wrong, like, all week. No week? Maybe. I don't know. Maybe we got something wrong at the start of the week. I don't remember getting something wrong. Maybe you do. I don't. Excellent. Well, let's do another chapter 5. We just got open floor on questions right now. Pull up another chapter 5 we haven't done yet. Trying to find a good one we haven't done. A lot of similar ones. That one has a very different ending to it because it's an improper usage. We'll do the football one because that is on the homework too. Football one's a bit easier. Football one is a similar type problem. Nice. So we'll do the football and the skiing one. I think we have enough time for real quick here. Let's do the football, Statue 1, Chapter 5 question, Part 2. Let's check it out. Check this out. According to the normal model, what % of receivers would you expect to get fewer than 2 yards? 2 standard deviations below the mean. So when you think about this right here, it's talking about a z-score of -2 because it's saying 2 standard deviations below the mean. So what % of football players would you expect to be 2 standard deviations below the mean? So be very careful. This graphic doesn't have the answer completely on here. But we're talking about we're at a z-score of -2. So you want to figure out, using your 95 rule, what this arrow I'm highlighting blue is. You can add up the numbers, and that'll be the answer. Or you could do the %, half the % outside. Awesome. Yeah, just practice. So what % would we expect to be 2 standard deviations below the mean? Vincent right there, crushing it, man. You're getting it. Yep, and then make sure to draw it out. Always draw it out. I've got my drawings ready to go when we do these problems. 2.5. For these data, what does that mean? Well, the mean is 330, 335, and let's check this out. Let's check out 2 standard deviations. Here we go. 1, 2, that's it. That's 2 standard deviations. So that's 2 standard deviations below the mean. Oh, we did the wrong mean. 1 standard deviation below. 2 standard deviations below. And look, -220. Go check for the answer. That means you're in the NFL and you're getting -220 yards. One of my guys got -1 yards. I hope that doesn't continue for the rest of the season. But you go this season with -220. I don't know if it's impossible. You're probably going to lose your job before it happens. It's about impossible. It's about impossible. Explain what the problem is. Right to the high, left to the low, whatever way
that monster man's tail goes. So this
is a right skew distribution. Monster Man right here. Monster Man got a right skew tail. And this is not normally distributed. So, there we go. I was like, where's my right skew? Boom, another one. Let's clear out one more question here. Hop back. Okay, so we're going to do one more question, I think. This one's a little tricky because this one uses the data along with using the empirical rule too. So let's check it out. The skiing question, chapter 5, part 2. Here we go. So this one has data right here to start. And in this data, we know that we have a mean of 103.83 and a standard deviation of 4.56. And then they give you the very exact time of 99.27. Now, this will always be exactly on a z-score that's a whole number. Let's check out observation. This is what we observe. Minus the mean, it's below the mean, so we're going to get a negative number. And look at that, divided by standard deviation. So this is going to give us the z-score right here. So the z-score is -1. So we want to find out the percent of times that are less than this. Now that we've turned it into a z-score, it makes our lives a little bit easier. So now that we have the z-score, let's go and look at our curve. And we're going to reshade this in from the last problem we did. Since we know the z-score is -1, we can go here and draw our arrow. And we can say in between here is 68. This curve's a little more broken down than we're used to. So what is one of these arrows worth? Yours might be different. It might say above or below. I think I'm doing below. So I'm at a z-score of -1, and then wants to know what's below. And it's going to be the outside of 68, and then half of that. Great job, Kayla. You're getting it. Yep. Practice, practice. We're getting it. And I think it wants the below, less than. Make sure it might say above. You never know. What is the actual percentage? So this was an estimate according to the empirical rule. Now it wants to know if we go to 99.27, we'd go right here, and we'd say there's 1, 2, 3, 4, 5 times below. Just want to point this out, how we're getting this. This is where 99.27 would be. Thus, there are 5 times out of 53 below, because there's 53 observations, it says right there. So there's 5 out of 53 below, and with 5 out of 53 being below, that's the percent that's actually below. We're going to drop it in, turn it into, we'll do that by accident. Be very careful. I'm taking risks. I think I've done it properly. Do the two percentages match up? Why or why not? 99% certain it always says no. If they matched up, the normal model would probably be appropriate, or it could be. If they don't match up, the normal model is probably not appropriate. So no, they do not match up because the normal model is not appropriate. The closer these two numbers are, the closer what we observe will be closer to what the normal model expects us to see. How does this distribution actually look? Well, do we have a lot of times around 122? Yes or no? Look at the data. Do you see a lot of times up near the 120s? Like this is how many occurrences there are. And this would be 4 occurrences up here around 122. Do you see that? I certainly don't. How about down here on the bottom? Let's look down here, 98. I do see, it's a bit more 98 than a gap. I don't see a gap. That one's eliminated. That one's not here. That one's not here. This is a little unimodal. This is more of a gap. Do we see the gap? Oh, we do. Notice the jump from 106 to 112, indicating right here we have the gap from 106 to 112, and the values go up to about 117. I think that is accurate because the other one doesn't have a gap. We need a gap between 107 to 112, and that looks to be that gap right there. So that's good indication in the data right there. What can be seen from the histogram? Choose the correct answer. The data are normal and are not normal and skewed to the right, which is even more confirmation that they don't match up. That's got it. Most of us means something wrong right there. Excellent work. I hope this one makes a lot more sense. We're looking at the histogram. They used to have a QQ plot on this. I swear they did. My Pearson must have not liked it. But with that, I think that's got it. We're going to end just 5 minutes early here. We got a lot of questions knocked out today. A lot of great work. Let me know if you have questions. I'll be around. Keep working hard. You got this. Stat 213, 320, 474, 475, 479, 471, all the classes. I'll see you later. Bye, Frankie. Bye, Vincent. Bye, Kayla. Keep up the good work. Let me know if you got questions. Bye for now, everyone. Bye. You're welcome, Vincent.
Till next time.